Hello, it's Joseph, and welcome to today's video where I show you how I build a lightsaber. Most of the parts that I got for this build came from the custom saber shop. If you're interested in building your own lightsaber, I highly recommend you check out their site. There is a bit of a learning curve to their site, but I have a list of videos in the description that help me learn how to build my own lightsaber, so you can use those to help you as well. The hilt pieces for my saber are made of aluminum, so the threads require a little grease to ensure that they stay in good condition. So I made greasing the threads the first step in my process. The plan was to put two switches into the gear piece, which required a 16mm hole for the main anti-vandal switch and a 3 to 5mm hole for the auxiliary switch. I also needed a thumb retention screw in the blade holder. I applied masking tape to the gear and the blade holder so that I could accurately mark where I drill my holes. I made sure to do this when both parts are screwed together and with a chassis disc and hilt side PCB holder between the gear and blade holder. I started by marking where my blade retention screw will go first. From there, I moved on to the main switch. I didn't want to drill holes into the threads of the gear part, so I was left with roughly 3mm of room on either side of the main switch, so there was very little room for error. Since I couldn't fit my caliper inside the part to figure this out, I used a piece of paper and measured that. I used a hand drill to drill my holes into the parts. If you have a drill press, I highly recommend using that instead. At all times, I used machine oil to lubricate the bits and taps. For the blade retention screw, I used a 1/8 inch drill bit after I drilled the pilot hole. Then I just used an 832 tap, carefully rotating it until the tension stopped my motion. Then I turned it backwards, allowing the aluminum shavings to be removed from the hole before turning it forward again. I just repeated that process until the tap went all the way through. The main switch hole was the most stressful part. This is where a drill press would have been much better to use, if I had one. I started drilling a 1/8 inch pilot hole. Then, using every drill bit in my possession, roughly about 16 of them, I slowly increased the size of the hole, constantly checking with my caliper to make sure that it was straight. As the bits increased in size, it got harder to control the drill, so I had to wedge it against my body to help keep it stable. The final bit was a 5/8 inch size. After that stressful task was complete, I used a step drill to recess the size of the hole so the wings of the switch would reset into the gear piece. The auxiliary switch hole was much simpler than this. I then assembled my chassis. I purchased a 3D printed chassis from Arms of Elam on Etsy to hold my Crystal Focus 10 sound card, battery, recharge port, and 28mm speaker because the custom saber shop holders were designed for parts with a wider inner diameter. The ribbed extension piece the chassis will go into is a 1.1 inch inner diameter. The threaded rods you see will screw into the speaker holder and help hold the whole thing together. Using my Dremel tool, I cut the threaded rods to the length I needed, then sanded down the jagged ends. I then cut the brass pieces to the desired length. The chassis setup is the most crucial to a lightsaber build, so it took a lot of planning time off camera. The recharge port allows me to charge the battery and kill power to the system when not in use. To fit it into its holder, I cut the metal ends to length with wire cutters, Dremel sanded the sharp ends, then screwed it into the holder. Then came the soldering. I pre-tinned the metal ends of the recharge port. Then after pre-tinning my wires, I soldered them in place. How to properly wire these recharge ports is in the CFX manual. One end was connected to two white wires. One of these will go to the negative pad on the soundboard. The other went to the negative pads on the main and auxiliary switches. The opposite end was connected to three red wires. One red wire went to the positive end on the battery, the second will go to the positive end on the soundboard, and the third will go to the positive leads on the pixel blade. The center connector on the recharge port was wired to the negative wire that goes straight to the battery. The battery came from the custom saber shop, was already equipped with a JST connector, so I wired one from the recharge port so that in the future I can remove the battery easily if it needs to be replaced. When wiring my LED ring main switch, it was important that I kept track of the LED leads and the switch leads. I marked the positive lead for the switch, and that helped me keep track of things. I decided to wire the LED first. After a brief test to make sure it will go into the gear piece fine, I then wired an inline resistor to the positive feed for the LED. In my case, an 82 ohm 1/4 watt resistor was required. After this was done, I applied heat shrink to protect the solder joints and carefully used my soldering iron to heat the shrink, since I don't have a heat gun. I have to be careful when I do this because I could melt my solder and then I would have to start all over. With the LED wired, then I just wired the switch leads. The auxiliary switch was once again a bit simpler. Just wire the positive and negative ends, and it doesn't matter which end you choose your negative and your positive to be, you just need to pick one. Then, with a little test to make sure the switches fit into the gear, I was able to move on to wiring my Crystal Focus 10. On screen I have a diagram for you that shows how I wired everything up. I also will be making this available to you in the description if you would like to try and use this to help you in your own lightsaber building project. To wire my CFX soundboard, I just worked my way clockwise around the soundboard. I started with the pads for the switches, then the 4 negative pads and data pad for the pixel blade, then the accent LED pads for my crystal chamber, then the switch LED pad and its negative pad, which by the way is shared with the crystal LED negative, and finally the pads for the Bluetooth module. The pads for the speaker and the main power were not wired until the board was placed into the 3D printed chassis by Arms of Elam. For the crystal chamber LEDs, I wired the red to the accents pad number 7 with a 91 ohm SMD resistor that I purchased online. The green went to the pad 6 and the blue went to pad 5. I used these pads instead of 1 through 3 because they gave me more lighting effect options. However, I did all this bridging on the underside of the board the first time, but after consulting with some people online and reading the manual a million times, I discovered that you need to bridge these pads on the top side. I eventually removed this resistor as well and put it in the wire line because it was causing me some trouble. For my bridging, I just used pretend wire. After the board was wired, I moved on to my 28mm bass speaker. I used a bit of foam to create a resonance chamber behind the speaker. All I did was trace it out, cut some holes for the rods, then glued it to the back of the speaker holder. A cross cut was made so that I could feed wires through it. Before soldering wire to the speaker, I set up a JST connector so that I can remove the speaker from maintenance without having to cut any wire. After soldering this to the speaker, I used a little hot glue to protect the joints. Before I was finished, a small amount of putty was placed around the speaker to absorb the vibrations. Then I screwed in the threaded rods and placed the brass spacers so that there would be room for the JST connectors between the speaker holder and the soundboard holder. Before mounting the sound card to its holder, I used the Dremel to sand down some grooves for the wires that supply power and an indentation to make it a little easier to remove the flash card from the board when I'm editing. Then it was time for assembly. The chassis from Arms of Elam has these channels to run wire, and I made use of them for the speaker wire and the wires that supply power. After braiding some wire to help me keep track of it all and to not make silly mistakes, I finally wired the speaker to the CFX. Then, after feeding all my wires into the desired locations, I soldered the power connections to the CFX. I then moved my attention to the hilt side PCB. This part has 7 pins that will make connections with the pixel blade. After soldering in these pins, the wires should be soldered into place. There are 2 positives, 2 negatives, and a data line. The PCB will then be screwed into its holder, which is sold separately at the custom saber shop. Next came soldering the wire to the BT630 Bluetooth chip. This chip unfortunately won't stay in my lightsaber as the aluminum casing kept interfering with the signal. I eventually upgraded to a BT909 with breakout board, both of which are available at the custom saber shop. It has a much stronger and more reliable antenna, but it is wired the same way as you see on screen. There's a positive, negative, TX, and RX connections. It is important to know that RX on the CFX, or the crystal focus, is wired to the TX on the Bluetooth module, and vice versa. After assembling the chassis with the spacers and the main disc that will hold it in place, I moved the gear piece into position so that I could solder all my wire connections. I used JST connections so that my whole setup was modular. This was very time consuming and completely optional to the process. The connectors take up a lot of space, so if you use a shorter hilt, you may not want to do this. I can always come back later and change this setup if I wish. The final step in all this was to screw my hilt side PCB into its holder, bunch up my wire, screw all the pieces in place, then give it a little test to make sure everything is working fine. The Pixel Blade is actually a pretty simple process to build if you have the right items. Rob Petco does a great job of showing you how to do this process in one of his videos. I linked it below. I used a 1-inch diameter thin-walled blade tube since this will not be for dueling. I first wanted a 36-inch long blade, but after testing it, 34 inches worked a little better for me. I just simply cut the tube to the length with my miter saw. The part that fits into the blade holder took a fair bit of sanding to make sure it will fit well. Sanding was probably my least favorite part of building the blade. After pre-tinning the PCB connector, I used masking tape to hold it in place, then another piece of masking tape to place my 0603 330 ohm resistor. This resistor is required to prevent your data line and LEDs from being fried. Then I removed the LED strips from their rolls and removed the protection around the wire solder joints as well as the 2 extra wires. Next, I cut and separated the wires on both strips to 1 1/4 inch, then pre-tinned the ends. I laid the pixel strips onto my cut blade tube to determine where to cut them. The strips have marked lines to help with cutting. I then cut the tips of the strips to 45-degree angles, making sure to watch out for the inline's resistor. This will help the strip fit better into the diffusing foam. On the back of one strip, the adhesive needs to be removed. The adhesive will not bond to the adhesive on the other strip, so this is necessary. I then place electrical tapes at the tip and a joint halfway down the strip to eliminate the risk of bridging. This is also done at the joints for the wires. After that, I placed the strips back to back on a flat surface and slowly pressed them together while removing the protection for the adhesive. I made sure to go slowly while pressing the strips down and checking to make sure the LEDs stayed in line. I did one final check to make sure they were pressed together before applying hot glue at the wire connection joints. When soldering the wire to the PCB connector, I used masking tape again and my helping hands to help get things into place. After soldering one side of the strip, I flipped it around, ran the green data line in between two other wires, then finished soldering the rest. The blade adapter fits into the PCB. Then I glued it in place with around a 1/4 inch distance between the adapter ring and the LED wire joints. The diffusing foam, which is used to diffuse the light from the individual pixels, is cut about 3/16 of an inch shorter than the blade tube. Once cut, I slowly ran the pixel strips through the foam, making sure to not let it bunch up or twist. There's a few tricks to do this, and you can see those in Rob Petco's video. The goal is to have a single LED sticking out of the end of the foam tube. Once that was done, I pressed the hilt side adapter in place and the blade tip in place. Weld-on 3 glue was used to keep the tip and blade adapter in place. Now for a test. With the main parts of the lightsaber working, I moved to the final steps for my basic crystal chamber. I found an old BNC wire connector from college to hold my crystal. After removing the wire and providing a little bit of cosmetic work with my Dremel, I tested to make sure it fit into my aluminum chassis disc. Since the crystal holder will be blocking the hole that allows wires to pass through, I had to cut off the bottom half of the disc, making sure not to slice into the holes that the threaded rods go through. Sanding down the disc after cutting was necessary to make sure no jagged edges were left that could cut my wires. The crystal holder was then hot glued to the cut disc. I may go back later and replace this with super glue or maybe solder. I bought the quartz crystal off of eBay. It ended up being a little too long to fit in place, so I broke it in half with a hammer, which I felt actually gave it a cooler look. The crystal is backlit with a single 5mm RGB LED from the custom saber shop. All I had to do was solder it to the wires I already had coming from the board. 1/16 inch heat shrink was applied after every wire was soldered to prevent bridging. A 3/16 piece of heat shrink was applied around everything to protect all the joints and to help it fit more snugly into the crystal holder. I discovered my wife's blow dryer made an okay substitute for a heat gun. I then moved on to adding some more customizations to really make this lightsaber feel unique to me. I decided to add a shroud to the blade holder. There was a store online that sold cheap aluminum tubing with an inner diameter that was really close to the outer diameter of the blade holder tip. To make this, I folded a piece of paper in half and drew one side of the shroud design. Then I cut it out and tested it before taping it to the tube. I traced around the paper onto the masking tape that was pre-applied to the tube, then removed the paper. I also wanted a shroud reminiscent of a shield design on the hilt where I hold the lightsaber. I used the same paper drawing masking tape tracing technique as I did from the braid shroud. The tube for the hilt shield is a scratch and dent tube available at the custom saber shop. After all the tracing was complete, I carefully cut out the shapes with my Dremel. It took 2 discs to complete this task, despite the fact that aluminum is a soft metal. I then sanded down the edges with a combination of Dremel sanders and different grits of sandpaper. Some well-placed, hard-to-see retention screws were used to hold the shrouds in place. I then moved on to drilling and tapping holes for Covertec clips so that I could wear the lightsaber on my belt. I also drilled a hole so that I could add and remove a kill key to the recharge point without having to unscrew the hilt every time to get to it. After all of this was done, I tried to program the crystal to match the blade color, and that's when I discovered that I had incorrectly bridged the bottom side of the board. So I made the adjustment and placed the resistor in the wire line for the red LED, and that got everything working. The final touch was to purchase a blade plug from Genesis Custom Sabers, build a simple pixel strip to fit inside it, and then I was able to display it on the shelf. Well, I had so much fun making this lightsaber project, and it wouldn't be possible if it weren't for the great resources out there and people that help make this possible. So I want to give a shout out to those people and resources that help make this happen. First off, the Custom Saber Shop. Without them, this build wouldn't have happened at all because of where I got most of the supplies. And they have a great Facebook group. They have a great website and forums to help anyone that is starting out on this process to try and guide themselves through building a lightsaber build. I want to thank Nick Krzeski, who created a great series of films on YouTube using a GoPro on his head and showing you how to go through the process of building a lightsaber with a CFX and a Neopixel blade. He's also active on my next place I want to thank, which is the official CFX group on Facebook, which is a great place to go if you're ever using the CFX and need technical help. There's people on there just like you and me who will give you some help. But also I want to thank Irv Plechter for building this Crystal Focus 10. It's a great soundboard, and he's also a really helpful person. Every now and then you can get in touch with him and he can help you through some of the things. And he's constantly doing firmware updates to try and keep the board credible and keep it in great tip-top shape. I want to thank saberfonts.com, where I got some of my saber fonts for my lightsaber. Great place for saber fonts. I want to thank Arms of Elam that created the 3D chassis that I used in order to make this possible. And then finally, the person who has made the most impact and the most influence has to be Rob Petkow at Genesis Custom Sabers. Those videos I spoke of that are through the Custom Saber Shop, he's the one that mostly made those videos and showed everything he's done. He has such a great website over there at Genesis Custom Sabers, and he does a great job making some amazing lightsabers. And the fact that he is so willing to share his knowledge and his expertise with the sabersmithing community is such a testament to his character and who he is. I think he's such a great guy for doing that. Even though, you know, he makes his living off of building sabers, he's so willing to share with people his passion and explain to you how to build a proper lightsaber. So I want to really especially thank Rob for everything he's done for the sabersmithing community. Well, that's our video. I so want to thank you all for watching, and I hope you enjoyed it. And once again, happy May the 4th.